Hello friends, I welcome you in lecture number 4 on permutations and combinations. In lecture number 1 to 3, we have discussed about permutations and combinations, and we had made one assumption that repetition of objects is not allowed. Whatever we have discussed in lecture 1 to 3, in that we have the assumption that we are doing the arrangements without repetition, and we have seen that the number of permutations of n objects taken r at a time without repetition is given by npr, and same thing for number of combinations of n objects taken r at a time. So if we are doing the arrangements or selections in which repetition is not allowed, then we have to use these two formulas which we have discussed in previous lectures. Now we are going to generalize this concept of permutations and combinations in which we will allow repetition of objects. Suppose repetitions of objects are allowed, then how to count the number of permutations or number of combinations. So that we are going to discuss in this lecture and upcoming lectures. So first we focus on counting the permutations when repetitions are allowed, and then we will see for combinations. So we again consider one example. Suppose I have three objects, say A, B and C, and I am interested in the arrangement of two objects out of these three objects. I want to consider arrangement of two objects out of total three objects. But here I assume that repetitions of objects are allowed. So first we count that what will be the total number of arrangements of these three objects taken two at a time. Now because repetitions are allowed, we can consider this type of arrangements also: A, B, B, C, C. Then we have AB, BA, BC, CB and AC and CA. So we can see there are 3, 6 plus 3, that is 9. So there are 9 arrangements or permutations are possible if repetitions are allowed. So here we cannot use this formula, that formula of NPR. This formula is for number of permutations of n objects taken r at a time with the assumption that repetition is not allowed. But here we have allowed the repetition. For example, if repetition is not allowed, then by this formula we have 3p2, that is going to be 3 factorial divided by 3 minus 2, that is 1 factorial, and 3 factorial is 6. And here we can see that if repetition is not allowed, then we have these 6 permutations. But because repetition is allowed, we have 3 more permutations, and those permutations are not counted by this formula, because this formula works if repetitions of objects are not allowed. So how to count the number of permutations of n objects taken r at a time when repetitions are allowed? So that is very simple. We can use the product rule for counting. For example, for this same problem, that we want to arrange two objects out of these three objects, we can apply the product rule. For example, we want to arrange two objects, so I am taking two boxes for two objects, and there are total three objects. So for this first box I have three possibilities. I can put either A, B or C in this first box, and for second box also, because repetition is allowed, I again take any of these three objects A, B and C, and it is necessary to fill both these boxes to complete this task. Therefore we have to multiply these two numbers, and that is nothing but 9, and we have seen that there are 9 permutations of 3 objects taken 2 at a time when repetitions are allowed. So this we can generalize for arrangement of n objects taken r at a time. Suppose we have total n objects and we want to consider arrangement of r objects where r is less than or equal to n. Then we have to arrange r objects. So I am considering 1, 2, 3, 4 and so on up to r positions. This is rth position, or we can consider boxes also. Now to arrange these on objects in rth positions, or to count the number of arrangements of n objects taken r at a time, we have to fill these r positions starting from this first position. This is first position, second position and up to rth position, because we are considering r objects out of n, or we want to count the number of permutations of n objects taken r at a time. So for first position we can put any of given total n objects. First position can be filled by any of given n objects. Similarly, second position can also be filled by any of given n objects. Why? Because repetition is allowed. Same thing for third position and so on. Rth position can also be filled by any of the given n objects because repetition is allowed. And we have to multiply all these possibilities because it is necessary to fill, or it is necessary to assign objects to each of these positions, and therefore we have to multiply this n r number of times, and that turns out to be n raised to r. This is the number of permutations of n objects taken r at a time when repetition is allowed. So this is very simple exercise or result, you can say, that if you want to count the number of permutations of n objects taken r at a time and when repetition is allowed, then that number is given by n to the power r. That I have written here, and this is a theorem that number of r permutations of a set of n objects with repetition allowed is n to the power r. Or we can say that number of permutations of n objects taken r at a time when repetition is allowed is given by n to the power r. We can have one more example. How many strings of length n can be formed from the English alphabet when repetition is allowed? So here we have to count the number of strings, and the length of the string is n. So suppose I am writing these positions, because length of the string is n, I have to fill all these positions: first position, second position and nth position, because length of the string is n. Now for each position I have 26 possibilities, because I have to use English alphabet, and we know that there are 26 letters in English alphabet and repetition is allowed. So for first position we can put any of the letters A to Z. There are 26 possibilities for first position of the string of length n. Now because repetition is allowed, there are 26 possibilities for second position also. Same thing for third position, and for nth position also there are 26 possibilities, and therefore we have to multiply all these things because we have to fill all the positions to construct a string of length L, and this is up to n times. Therefore we have 26 to the power n strings of length n that can be formed from the English alphabet. So whenever you have this type of problem, you have to write systematically. We know that there are 26 letters in English alphabet, and because each letter can be used repeatedly, that is repetition is allowed here, there are 26 into 26 and so on, n times 26, therefore that is equal to 26 to the power n strings of length n. So in this way, whenever repetitions are allowed, we have to take care that we do not use the formula of NPR. This formula is valid whenever repetitions are not allowed. So in the examination, if repetitions are allowed, they will mention that here repetitions are allowed, and accordingly you can use the appropriate formula to count the number of permutations of n objects taken R at a time. And we have some another concept of permutations with repetitions also, that we will discuss in upcoming lecture. Thanks for watching.